Well, hello there. I hope everyone's doing well. Welcome back to another fun-filled day for SAT math and reading. I am Mr. Anthony Weinkoff, and I'm one of the directors of Embrace Tutoring and Educational Services. So if this is your first webinar and you are joining us, a few quick tips that I'll mention is that you want to open up the chat feature to the left or right of your screen. I'm actually going to post a quick agenda for you guys now so that way you guys have it, hyperlinks and everything included. Right, so you guys have what you need. I would definitely encourage you as we're going throughout the practice problems, and I'm going to do my best to get through as many individual problems as possible. I would definitely encourage you to ask questions as we're going through. You're more than welcome to just simply kind of pose a question in the chat feature, and I'll do my best to answer it live, right, so that way you guys have it. Also, a lot of the questions today are focused on one particular exam for practice test 1. Even if you may have covered practice test 1, I'm going to do my best to show you some sort of kind of quick tips and strategies that way you know how to kind of associate and like what to look for in the problem. So I hope you gain a lot of value, even if you've done some of these particular problems in the past. And then finally, a lot of the practice problems that you guys are asking for are being requested. So many individuals are requesting these problems either through the Instagram page or YouTube channel, or many of you guys are sending me personal emails, which thank you, right? Thank you for kind of I hope you're staying safe and healthy and kind of washing your hands during this entire process. So we just kind of want to do our best to give back and make sure that you guys are in a good place with respect to the SAT math. So let me know if you have any questions along the way. If there is something in particular that we weren't able to cover during this seminar, because we will do about an hour of math, and then as requested, we're going to do about 1 hour of reading. I'm going to walk you through the major reading strategies of the passages. Just simply send me a quick email. I posted my email in the chat function. For those of you that might be arriving to the webinar late, I'll post it again so that way you guys have it. And we're going to get started momentarily. And we're going to start with the math section. We're going to rip through a number of those particular problems for practice test 1. We're purposely going to go from easy, medium to hard, so to speak, as the test builds on. We will do some concepts that we've covered before, but we're just going to look at it in a different type of problem, so that way you guys have a better understanding, okay? So if this is your first webinar, a quick review in terms of what to do, and I know many of you have joined us in the past. A few quick suggestions. 1, post the questions in the chat. 2, you are more than welcome to take all the screenshots you'd like. If there's something you can't find, or you may not be aware of what particular problem we're on, just simply ask. I'll do my best to kind of let you guys know. And if you need any sort of follow-up, you're more than welcome to send me an email to weinkoff@embracetutoring.com for anthonyweinkoff@embracetutoring.com. Okay, so I definitely encourage you guys to take screenshots throughout. Okay, also we will be using and working off of this book primarily in terms of SAT College Board, right? The big blue book. If you've utilized this book in the past, it's completely fine. We're going to sort of break down different word associations and strategies like I'd mentioned. So just feel free to let me know if you guys need anything else. Some other major resources I would suggest for you guys to utilize and take advantage of. You probably want to subscribe to our YouTube channel. We have a number of practice tests and videos broken down explanation by explanation, which I will post in the chat features for you. I would probably also suggest to start a Khan Academy account to kind of work through daily practice, maybe 20, 30 minutes a day while you have it, okay? Now for the SAT math section, every problem that we look at, we're gonna cover it in 3 different ways, right? And the first is in terms of the major math strategy in a nutshell, is we're going to make sure that we read the problem, assess the type of concepts, right, or what content you've learned in the past that's going to be associated with the problem. We're also going to evaluate what is given in the problem, and we're going to think about how to utilize that given for majority of the problems. And then finally, we're going to connect that problem by solving what the relationship is within the given, right? So it's always, everything they give you essentially is a tool, so try not to overthink it. And then we're going to figure out how to utilize that given so that way we can kind of correlate that. But once again, any questions, either chat or send me a quick email so that way we can all be on the same page, okay? So we're going to get started momentarily, and we are going to begin with practice test 1. And for practice test 1, some of you guys have asked to do a systems of equations problem. We've done systems of equations in the past, like parallel lines and perpendicular lines, but some of you asked for more of a kind of a classic problem of kind of knowing what to do and a quick way of solving that, so that way you kind of know how best to utilize your time. So I'm going to do that first, and then the questions will gradually get harder, and I'll show you some other kind of quick tips to be aware of, okay? So I'm in practice test 1 right now. The hyperlink is provided in the chat function. I'm gonna slide down and I am going to go to number 9, I believe, in section 3. Section 3 is the non-calculator portion. Majority of the questions that we do, actually, to be fair, I'm not going to use a calculator for. There might be some that I might use a calculator for just to kind of save time. But I would even encourage you, and for most of the time when I do the SAT, I would only use something like this, because rather than sort of lean on a graphing calculator, I would get more accustomed to knowing the strategy, right, of like how to maximize what to look for. And I usually never use a calculator when I do the SAT, or like when I'm tutoring or with the tutors or students. So it's something, it teaches you sort of how to pay attention to certain things and how to utilize the given. That's probably a suggestion I would make. Now, if you do use a calculator, it's completely fine. And I would also argue that's on test day, you want to utilize it as a resource. But make sure that whatever calculator you're using, you're actually using that exact same calculator on test day. So that way it's a benefit to you, okay? So we're gonna do number 9 in section 3, and this is number 7. So here we are. This is a classic systems of equations problem, so you guys can see it. Now, the first thing I know about if this is gonna be a classic systems of equations problem, so I'll set this up. Now, we talked about systems of equations before, and some people have requested this particular type of setup, right? The systems of equations before, just as a kind of a quick review, is you have something that will look like, right, where the lines will intersect, right? And then that is going to be like one particular point of intersection, which is going to be referred to as like your XY coordinate in systems of equations. You'll also have something, and this is like the previous problem that we did, which is why I wanted to do a slightly unique or separate problem, is you're going to have something where maybe these lines are parallel. And if the lines are parallel, then that systems of equations will actually have no solution. So you want to be aware of the terminology. So if they give you some sort of coordinate here, like an XY, this is the type of problem we're going to do now. And then you can probably either use, I would say, elimination or substitution method. I generally use elimination on the SAT just because it's faster and sort of less to write down if you can do some of it in your head. But I know a lot of you guys might prefer the substitution method, so I can do it both ways if you wish. It's completely fine, or I can send you a separate email. For parallel lines, when it's no solution, this is the terminology that they'll say. They'll say the systems of equations has no solution, which is a previous problem that we had done, and I can send you follow-up YouTube videos. Or you might have something where both of the lines are actually together or on top of each other, and you may not know that. And this is referred to as infinite solutions, okay? So these are 3 different types of systems of equations problems for how they set it up. And we did this one before. We talked about infinite solutions, and some of you guys requested to actually do like a standard systems of equations, which is why we're doing this problem relatively quickly now. Okay, so here's what I see. If I break this down, and I see 2 stacked equations. And it says, what is the solution, x, y, to systems of equations above? So I'm going to circle this real fast because that tells me it's the systems of equations. And in a very quick like nutshell, it means that the x and the y's are both equal to both expressions, right? That's essentially what it's saying, is that these x's are actually equal and the y's are also equal. And that is what corresponds to them intersecting at a particular point, right, when I have that coordinate. So if I graph both of those lines, which you do not want to do, right, in systems of equations, it will take a while, then that point of intersection here, that's actually what will pop up if I figure out what is x, y. So here's what you want to do instead, okay? When you see stacked equations like this, and you obviously see the phrasing systems of equations, instead what you want to do is you want to decipher which one should you solve for, right? Should you solve for x or should you solve for y? And what I mean by this is that I'm going to set this up in an elimination method usually first. You could solve for x or y using substitution, which means you solve for x and then you basically plug it into the other equation. That's what substitution refers to. But I'm going to purposely use elimination because of the fact that that allows me to take my answer choices a little bit more into consideration. So here's the deal. This says A is -5, -2. This is B is 3 is -8. C says 4, -6. And D is 9, -6. Now notice this. I have 3 different choices for Y And here I have 5 or 4 different choices for x. So if I solve for x and not y, I have a better chance of getting the question right immediately, right? And that's the goal in terms of me using my answer choices. And it also depends on the multiple that I see here, right? Like, is it easier to solve for x or y first? And sort of that will be instinctual for you. You'll see it and you'll know kind of what to do. Now, because of the fact that my answer choice is here for x, I want to solve for x, right? Because if I solve for x and if I trust my math, then what happens is I'm done just solving for x if I really trust my math, versus I have to solve for x, then I have to plug in, then I have to solve for y, and then if I want to be a hero, then that's what I do, right? But if you trust your math in order to solve for x, then you just solve for x and you're finished, right? So that's sort of a quick strategy to use. Now, if I want to solve for x, which is the method I'm going to use, then I'm going to eliminate y. And if I eliminate y, that means I need to find my common multiple. I need to find the common y multiple here. Now, very quickly, what I'm going to do to make this easier for you guys, and you're welcome to take a screenshot if you wish in terms of the strategy, but actually I'll write down a little bit more so you guys can see it. I'm going to actually immediately kind of multiply by the common multiple for y. Now, if y is the common multiple, then I'm going to multiply, then I'm going to multiply the bottom equation by 2. And the reason I'm going to multiply the bottom equation by 2 is because I want this 2y to become a 4y, so I can add or subtract these stacked equations together. So if this is a 2 here, then what I end up getting when I distribute that is it now becomes 4y, right? I get 4y, and I'm going to do minus 2x equals negative 38. Now remember, and the most common mistake, if you understand the math and you understand the strategy and you're like, oh man, I know what to solve for, the most common mistake is that students actually forget to multiply the other side of the equal sign, right? You just multiply here as if you're distributing, but you might forget how to do, right? You might actually you might forget to do the 2 to the negative 19. So remember to do that so that way you have it. So this now becomes 4y minus 2x equals negative 38. Now this equation is set up appropriately. I have what I need for the 3x plus the 4y equals negative 23, but I'm going to arrange it a little bit so that way you guys can kind of see it more visually to make it easier for you. So I hope this doesn't confuse anybody, but I'm basically going to move the 4y out to the front, right? So I have 4y, and now I'm just going to do positive 3x like this, and then I'm going to do equals negative 23, okay? Now, some of you might be debating, hey, couldn't you just multiplied everything by like negative 2x in the beginning? Yeah, I could have, that's fine, but I also trust my ability to just simply do subtraction, which is what I'm gonna do. So if I could multiply by a negative 2x in the beginning to make this a negative 4y, and then I add the equations, but I feel pretty confident that I can do subtraction. The second most common mistake for systems of equations problems with these is when you add or subtract something, you forget to do the same to all of the rest. So you will make a common kind of addition or subtraction error. Now, I want to subtract these equations, and the whole reason I'm doing that is because I want to get a 0 for my 4y. This is the process of elimination, right? I want to solve for x, so I'm finding a common multiple to eliminate y. So 4y minus 4y becomes 0, right? So I removed it, I eliminated it, it's gone. So now I have negative 2x minus 3x, right? So don't make the rookie mistake of doing negative 2x and then plus 3x. It's negative 2x minus 3x, which becomes negative 5x, okay? And then here I have negative 38 minus negative 23. And a quick thing, remember a negative to a negative is simply a positive. So this is actually negative 38 plus 23, which is the difference between these, which is 15, okay? So if this, or negative 15, right? So negative 38 plus 23, this is negative 15. Now look, my answer choice is here, right? So now I'm just gonna simply isolate, I'm gonna solve for x in this way, right? And now I have negative 5, right? Divide both sides by negative 5. This cancels, and what would you know, negative 15 divided by negative 5 will give me x equals 3. Now I'm done. Technically speaking, for the strategy that I used, I'm technically finished. I know B is going to be my answer. However, in classic math, you guys are usually asked to solve for both. So I'll quickly solve for both. That way, if necessary, if you need to solve for both, you sort of quickly understand kind of what to do and how to do that. Now, let's pretend for my x's, I had more than one answer with a 3, right? Because if I have more than one answer with a 3, now I need to do the next step, which is I need to plug back in order to solve for that. So the $1 million question is, well, which equation do I want to use to plug back in? You can use either one, right? You can use whichever one you want. You can use the 3x plus the 4y equals negative 23, or you can use the 2y minus x equals negative 19. The question is, which one is easier for you to do? So realistically, you do not have to use you don't have to write a ton, right? That's really your goal. You don't get to use a calculator, so you want to eliminate trying to write as much as possible. So I'm probably going to use the 2y, right? So I'm going to use the 2y minus 3. I'm just simply plugging in my 3 here to solve for the y, and then I'm going to get minus 19, okay? I'm going to add my 3 to both sides to isolate, right, because this was the x, right? That's where that minus 3 is coming in. I'm plugging in my x here, and then I'm going to get 2y equals my negative 16, y equals negative 8, and my answer should be that. Yep, B is still right. B is good. Everything is good. So notice what I did, though. The strategy, why do we subtract the 2 equations? It's a really good question. I'm trying to eliminate the 4y. That's the whole reason why I'm trying to subtract these equations to basically get rid of the 4y. That's the whole idea behind elimination method. And it's one of the reasons why a lot of individuals asked to do a problem like this, because they wanted to sort of see what the quick strategies were. Now, some of you could definitely solve this, like sort of old school, and I know you can probably plug it in and everything, but I'm sort of telling you like how to look at the problem so you can kind of maximize it as much as possible and not kind of like overthink it. So I'm subtracting the y's because the first thing that leads it is that my x's are all different, right? If I look at my values for x, I have 4 different answer choices for x. I have a negative 5, a 3, a 4, and a 9. So if I solve for x by eliminating y, by finding what the common multiple is, then I'm home free. I basically I'm done the problem in essentially one equation rather than having to do multiple, right? That's the reason why I'm subtracting the entire bottom equation here, right? The negative 4y plus 3x equals negative 23. If I subtract this to get to 0, I have to subtract the rest of it. I have to subtract all of it. Some of you will argue, well, I generally prefer to do substitution. That's cool. If you want to do substitution, go for it. Just be mindful that if you have a coefficient out in front, here's a thing that I'll say to you. Let's say in the bottom equation I want to solve 2y minus x, right? So let's say I have 2y minus x equals negative 19. Well, you kind of need to know how to tackle the problem relatively quickly before you start, because otherwise what will happen is that, let's say I want to solve for y, right? And I bring this x over. Then I get 2y equals negative 19 plus x. Well, now I need to divide by 2, right? In order to get rid of the fractions here. So this becomes a 2, this becomes a 2 like this. Now, if I'm using substitution, this is my value of y, and I have fractions, right? So now I have to plug this into 3 times negative 19 plus x over 2 plus, right, 4y and equals negative 23. That is not fun, right? I don't want to do this. So I can't. And by the way, this is more writing. This is more writing. It's taking more time. I prefer to stay away from this mathematically if I can. So instead, it's just easier for me to multiply by the common multiple. I subtract them, I eliminate. That's the reason why on most SAT problems, you generally will lean towards doing elimination when it's strictly just substitution or when it's strictly just systems of equations. You will use substitution more often than not, and I can do a problem that's like it when you're doing quadratics. Like if you have like 2 lines that are set equal to each other and you're kind of plugging them in, okay? So I hope that kind of explained everything. Feel free to take a quick screenshot. We're gonna move on to the next particular problem. And like I said, I'm definitely sure that a lot of you guys know essentially what to do and how to tackle this problem, but I wanted to do it because some of you had requested, hey, how do you tackle a systems of equations problem like relatively quickly? Like, hey, Mr. Markov, how do you do so many of them in your head? Like that's essentially what I do. That's what I look for and like how to do the math, because the hardest part about this is me doing negative 38 minus negative 23 in my head. And if I can do that in my head, then I get negative 15, right? And then negative 5x divided by 3, boom, A, B, done, circle, move on, okay? So we're gonna get rid of that. Let's go to the next particular problem that we have. Oh, some of you requested how to do a quick absolute value problem. You wanted to know how I did those relatively quickly. So I'm going to go to section 8, or I'm sorry, practice test 1, and we're going to go to number 8 in section 4. Okay, so how to quickly do an absolute value problem that looks something like this. And my first thing, when it says for what value of n is negative, or the absolute value of negative n minus 1 plus 1 equal to 0. So this is what I want to set it up, right? I want to quickly kind of set up my expression, and I get absolute value of n minus 1 like this, right? And then plus 1, and then equals 0. Now, here's the one thing you really have to kind of understand with absolute value, and the SAT doesn't really like assess it too much, is that this output here always needs to be positive, right? So, or just positive in general, right? Not necessarily positive 1, it just needs to be positive. So the output of any sort of absolute value, right, like this in general, will need to be a positive value. What tells me about this problem, and the thing that they like to do, is they want you guys to spend a lot of time on it, but here's the thing you kind of have to like quickly figure out, is that if I quickly skim my answer choices, there's no such value of n. So you're thinking to yourself, okay, why is there no such value of n? And before you get into the whole, hey, I'm going to do n minus 1, and then sort of set this over here, right? And I'm going to do equals negative 1 like this, right? Before you get into the two differences, right, where if you do n minus 1 and n minus equals positive 1, that's how you set it up. If you're looking for the two differences between them, the first thing you need to quickly like conceptually understand is if this is even possible to be a negative value, right? That's the first thing you need to understand, is that if I have the absolute value of n minus 1 here, plus 1 equals 0, and if I subtract this 1 over to the other side, then there's nothing you can plug in that relatively will work, right? If you end up solving these through, you might get these possible answer choices, but they're incorrect, because the simple fact is anything, the output of an absolute value here, when I have my n minus 1, right, equals negative 1, right? This is not possible, and that's a trap that they're trying to set for you. So just be aware that if you have some sort of absolute value on your on the SAT, the first thing you look for, okay, just a huge tip, the first thing you look for is if this is a positive value here and you're immediately kind of crossing it over to the other side, like algebraically, then it's not possible. So D is your answer, right? So without overthinking it and doing too much work and kind of going down that avenue. And in future webinars, I can do other, right? I'd be happy to do other types of absolute value problems for you. There's probably only a few even listed within the book. And we have some that we've developed our own, but realistically, this is the most common incorrect, or this is the most common correct answer for absolute value, because what they're really trying to do is set a trap so that way you don't see that this is actually a negative value, right? So nothing for absolute value it's always positive. Okay, so there's something, a quick trap that you guys want to pay attention to. All right. Now, the next question that we're going to cover is number 14 in section 4. So I'm going to go down to here. This is also a quick kind of suggestion or tip that some people have asked for. They wanted to know the mode, median, mean, and range problem. So if I look quickly here, right, the table above lists the lengths to the nearest inch of a random. So first of all, I'm skipping all this because this is a lot of information and I don't necessarily need it, right? We're on number 14, practice test 1. And because some of you were asking, number 14, practice test 1, and we're doing number 14, okay, for section 4, okay, for the calculator section. And it says table above lists the lengths to the nearest inch of a random sample of 21 brown bully fish. Okay, so there's a total of 21 for my first. And it says, no, notice I immediately put that in the denominator. I'm gonna tell you why. It says the outlier measurement of 24 inches here is an error, okay, of the mean, median, and range values. So even better, we're gonna do a quick recap. The mean is your average. Okay, so it's your total sum over the total sum of all of the numbers, okay, divided by the total amount of numbers there are. Total amount, I guess, of like participants in the study or of the research, right? So the total sum is if I add all these numbers up. The total amount is if I count the actual number of increments there are, right? Actual number of values submitted. Your median is your middle value, and it's your middle value of the data set when everything is in numerical order, okay? So everything has to be in numerical order in order for this to technically, the most common incorrect answer when you're finding the meaning is you forget to put it in numerical order. Your range is simply your highest minus your lowest, right? Your high minus your low for these things, which is probably the easiest thing to figure out. And I'm also gonna put a little star here because I want to tell you that if you change things in a data set, usually the range is the thing that's affected the most. So I'm just gonna put a star next to this question. And then it says they will all change the same amount in every way, which I'm gonna let you in, that's definitely not gonna be the case, right? More often than not, when you have a bunch of different values in a data set, this answer is usually not gonna be the case. All right, so which of the following, the mean, median, and range, which will change the most if I remove my 24-inch measurement for the data? Now, this is a really popular type of question that they will ask you if they ask you some sort of mean, median, mode, and range. And here's the reason why. It requires a lot of work if you don't quickly understand it conceptually, okay? So the first thing I'm gonna do is I'm gonna describe it conceptually, and then I'll quickly sort of write out the work so that way you guys can see it, all right? And feel free to, as I'm writing everything and you see, feel free to just post questions in the outside box. Oh, quick thing. If they do ask the mode in this instance, that's just the number that occurs the most often, right? It's the number that's most frequent or most often in the data set to kind of break that down and make it easy for you. So I'm gonna get rid of this stuff here to give myself a little bit of room for writing. So I'm actually even going to include the mode in this, so that way, if heaven forbid you had to figure all three of these things out. So I'm even going to do this. I'm going to organize it in a way so I don't get confused. I'm going to do the mode of 1, and I'm going to do the mode of 2, okay? And then I'm going to do the median of 1, and then I'm going to do the median of 2. And you're going to see what I mean by 1 and 2. And then I'll do the range of 1, and I'm going to do the range of 2. And then finally, I'm going to do the mean of 1, and I'm going to do the mean of 2, okay? Now, I'm going to let you in on one other secret. The mode is usually the easiest thing to find. The range is usually the next easiest thing to find. The median is then actually, believe it or not, the next easiest thing to find, because you guys love to do that cross out thing, right? The whole sort of old school where you go like this, right? And then you sort of find the middle value by going through the middle. I'll do that in a moment. You'll see what I'm talking about. But the mean is actually the hardest thing to find. And it's the thing that takes the longest. So what you need to do is, if you can rationally answer the question before getting and solving the mean, try to do it. Otherwise, it will take you, this is the difference of whether or not maybe you sometimes solve the question in under a minute. I'm going to do all of them, and I'm going to do all of them in under a minute, but just hang in there so you guys can see. I'm also going to quickly tell you that conceptually here, and I'm going to solve the mode and the range first, and I'm going to tell you why conceptually the answer is probably going to be C, okay? And it's because when I look at my data set, I have 3 9s, I have 2 10s, I have 2 11s, I have 12, 12, 12, 12, 12, I have 4 12s, so 12 is going to be my mode the second time, or the first time, and I have 3 13s, 2 14s, 2 15s, 1 16, 1 24. Okay, the question is asking this: if I keep my with 24, or if I'm without my 24, right? That's what it's really asking you. It's asking you, hey, the 24 is an error. What happens to these values if I get rid of 24? That's what it wants to know. So what is my first value with 24? What is my first mode, median, range, and mean with 24 in my data set versus what are all my values, mode, median, range, and mean with 20 or without 24, if I get 24 out of there. Now, my mode is the same, if you can sort of quickly understand, because my mode for the first is 12, right? 12 appears 1, 2, 3, 4 times. Well, if I get rid of 24, mode is still going to appear like the same amount of times. It's still going to appear 4 times. So my answer will not be mode, and my answer won't be mode because, and if I go back and if I like really try to kind of highlight here what you need to find, it says which will change the most, right? It wants to know what is the biggest difference between them. So the biggest difference, if I have to circle this, right, what will change the most? The biggest difference is just between the first set versus the second set. And this is the same. So mode will not be, mode isn't even in your answer choice, but I'm letting you know now, mode is not going to be the thing to change if it wasn't your answer choices. I'm also going to guess here that median and mean really won't change that much. And here's the reason why, is because this is a difference of 1, right? And then here is also a difference of 1. So if I include the 24, right, it's obviously going to elevate my median and it's going to elevate my mean a little bit, but it's not going to elevate it a difference of 8. So where did I get 8 from? Well, if I have to figure out the range of the first, which is I'm including the 24, right, then this becomes 24 minus 8, okay, which is 16. That's the range of the first data set. The range of the second data set, I get rid of 24, and this becomes 16, excuse me, minus 8. This is 8. Well, this is the difference. That's what they want to know, right? What's the difference between the first data set and the second data set? So the difference is going to be 8, which is going to be huge. And that's why I'm thinking range is probably going to be your answer for this particular question. And if you notice here, your median for the first and how, okay, so how do we quickly kind of figure out how to do median? Well, what you want to do for median is you want to line everything up in numerical order, and thank you, College Board, for already doing that for us, right? If I have everything in numerical order, I just want to simply cross them off, right? I want to find what the middle term is, like in between, like this, right? And then and then this guy, this goes away, and then this, right? You can also figure out the median by just simply subtract or taking the between the within the 24. If you know there's 21 values, right, then there's other ways to figure out the median. I'm just doing it this way so that way you guys can see it visually. All right, so my median here is going to be 12, right? So that's my first median. Now, let's pretend that I have 24 or I don't have 24 in my system anymore, right? Then my median is simply just going to shift back a little bit, right? Essentially, because I now have 20 things within my data set, so it's going to be between my 10th and my 11th value. So here I have 1, 2, 3, 4, 5. So 8, 9, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? It's still going to be 12. It's still going to be 12 out. So this won't change at all as well, right? My median will be the same. My mode will be the same. My range is a difference of 8. So I need to logically think to myself, okay, well, now if I choose the mean, right? If I sort of clean this up a little bit so you guys can see, and now if I actually have to do math, like if I have to like count all of these up, and luckily we're in section 4, so we don't have to worry too much about that of using calculator. But basically, I want to count all these up for my total, and then I want to divide by 21 for the first time. So my mean of 1, if you need to do this, is I take the total of everything added, okay, and then I'm going to divide by 21, right? That's the total number of numbers that I have. Versus my mean of the second one is going to be the previous total I have, and I'm simply just going to subtract my 24 value, right? Because I'm removing my 24. And all of this is going to be over 20 numbers, right? Not necessarily 21. I will tell you, you're welcome to do the math. I think it's a difference of like 0.4 in terms of like 0.5. This is how you set the problem up. And I will tell you, and so we can sort of move forward and maximize our time and get through some of the other harder problems. The range is definitely going to be the biggest difference. So if you take the total of all these numbers and then you divide by 21, you're going to get like 11 to 12, like in that area. And if you do it again, you're going to get the same thing. You're going to get 11 to 12 in that area. So they're only a difference by like half of a point, if that. And logically, you can kind of think through that because you're thinking nothing is going to shift more than 8 once you're able to actually determine what the range is going to be. Okay, so there's a quick tip of like how do you actually work through the statistics of the entire problem and kind of understand conceptually what's happening. All right, so take a quick screenshot and we're going to get ready to move on to the next problem, which is we're going to do and arguably I would say the two hardest problems on SAT practice test 1 because you guys requested them. And then after we get through those particular problems, we'll get ready to, I'll take any sort of like last minute questions you guys have, and then we'll get ready to move on to some of the reading strategies, okay? So here we go. And now for time purposes, I'm gonna do number 30 first because it's actually faster, believe it or not, in terms of the work and kind of working through the problem, because I'm purposely gonna do number 24 kind of a classic way, since some of you guys had asked for that. So here's what I have. For number 30, and SAT practice test 1, right? Section 4, number 30. SAT practice test 1 and section 4. So you have a chance to kind of find it. Now, here's what I noticed first about this problem is that it's a graph, it's a parabola, right? So the parabola goes like this. They actually give you a vertex here, which you should be able to denote that that's what they're giving you, right? That this is actually a vertex. You should also remember what vertex form is, just in case if you have to use this in some way, right? You should be aware of what vertex form is. And so now I'm going to go down and I'm going to read the question to better kind of ascertain what it is that they need from me, of how I'm actually going to break this down. It says, which of the following is an equivalent form? So the moment they mention the word form, I'm usually thinking vertex form, right? Because whenever they say, hey, which of the following is an equivalent form of some sort, and they're giving me this form up here, and they're giving me a parabola for some way, usually it's telling me I'm leaning towards vertex form. It then says the graph shown in the XY plane above, from which of the coordinates of vertex A can be identified as constants in the equation. Well, that's exactly what it is. So this is what they're telling me, that the parabola is hinting towards vertex form. So here's the thing you have to take out of this problem, is that first and foremost, many of you will probably attempt to factor, right? Many of you will get suckered in to just factoring as such, right? However, this is what is referred to as a standard form, right? So if this is standard like this, this form here is actually not the vertex form, right? Because the form that you see before you here is just standard factors. Vertex form requires one unique step in between. And some individuals have mentioned, well, I'll do negative b over 2a, and you can do other things. That's completely fine. I'm going to show you essentially how to what is called complete the square, which is the step you need to do in order to make this a perfect square, right? That's where the 2 is coming from. So if you ever get something on the SAT where it's a parabola, they hint that you have a vertex as symbolized by A, they actually state that there's a vertex, and you have something that is not in this form, right? It doesn't have a square going to it with 2 parentheses sticking out. That means that it's not in vertex form. So if it's not in vertex form, you have to figure out a way to get it to that vertex form, all right? So here's what I'm gonna do. I'm gonna break down for you, because this is not the right way to do that problem. That's more or less factoring it into standard form. So I already know A and B are gonna be out, right? Realistically, I know these are not gonna work because these are just standard factors of how the problem goes. So I know it's gonna be somewhere between C and D, all right? So I'm gonna get rid of this stuff. And I'm actually gonna write it on a separate screen so you guys can see it, but this is the equation that we need, okay? So what we want is the x squared minus 2x. Let's get rid of this. All right, so I want x squared minus 2x, and I believe it was plus 15. So quick reminder, this is what we refer to as a standard form, okay? We want this to be converted into something with like an x minus h squared, right? This is the form that we're going after. We're going after basically making this a perfect square in some way. So because of the fact that this is in a standard form and I want to end up finding a way to make this a perfect square, then what I'm gonna do is I'm gonna set this equal to 0, and I'm gonna subtract the 15 to the other side first, right? So if I subtract the 15 to the other side first, then what I'm gonna get is negative 15 equals x squared minus 2x. And I'm also gonna do this, I'm gonna leave a space here. And the reason I'm gonna leave a space, as you're gonna see in a second, is that I want to factor this to basically make this a perfect square. And my goal is to make it look like this, right? That's my goal. I wanna make this, whatever this is gonna be factored to, I wanna get it to be this form in the long run, okay? And here is what I'm gonna do. So I take when I mentioned, okay, we're gonna complete the square, what we're really gonna do is I'm gonna take my middle value here, which is -2, okay? And I'll write it up top here so you guys can see. I'm gonna take -2 and I'm actually divide it by 2, right? It's always the same process. So I'm gonna take -2 divided by 2. This will give me -1. I'm then gonna take the output or the answer of that, and then I'm gonna simply square it. So here's what I have. So here I have -2 divided by 2, right? Equals -1. And then I take -1, I square that value, and I'm gonna get +1. And now this should factor to be a perfect square, right? X times x is x squared. X times -1 is -1x. And then -1 times x is -1x. Those two things come together, give me a combined -2x. And then -1 times -1 gives me +1. So check out what I did, x minus 1 squared, right? That was the whole reason I did that form, okay? Here's the common mistake a lot of students will make when they're doing completing the square problems, is that once you understand the method, or like conceptually, like how to actually get this, is you will forget to add the same value here. Notice I have the +1 here, so therefore mathematically I have to add a +1 to the other side of the expression. It's basically like balancing the equation, kind of, if you think about it that way. So here's +1, so therefore I have to have +1 here. So this becomes -14, right, on this side. So notice -14 equals x minus 1 times x minus 1. So this becomes, right, -14 equals x minus 1 squared, which means if I bring this -14 back, right? Now, I didn't bring it back before because I purposely wanted to factor this first. If I bring it back in advance, well, check that out. I get the exact same thing I started with. That was the whole intention of not doing it. So I separated to purposely keep it organized. So here I have -14 plus 14, and I'm just going to add this over here. So my answer is going to be x minus 1 squared, right? And then plus 14. That's what I believe that's what it should be if I did it the right way. I didn't do it the right way. I made a calculator error, but I definitely know it's got to be -16. So what did I do wrong in terms of this is -14, add it. There's something that I did where these two things added together essentially should become -16. Right? That's what I'm, and I can sort of go back and kind of decipher everything, but for time purposes, we're going to move on. But completing the square was mainly the major objective of what you wanted to get out of it. So this is going to be your answer here, x minus 1 squared, which, to tell you the truth, I could have deciphered that just by using the x minus 1 squared. The -16 is some typo that I made somewhere in terms of the +14, right, with the +1 and the +1. So my suggestion would be to rework the problem, and the biggest thing that I would say, the takeaway, is that when you have a parabola here, you have a standard form, and they mention vertex, you immediately are attempting to complete the square, because what your goal is you want to get this form here, right? That's your overall goal. You're trying to get something into that form by making it a perfect square as you work through, okay? So let's go back to, I think, the last problem that many of you had requested was number 24, which was an equation of a circle. Now, I'm going to do this problem sort of slightly the long way, but what I will tell you is that you can actually input your answer choices into the equation of a circle, But I'm going to do it the long way on purpose because I want to show you conceptually what would happen if they didn't give you the answer choices, right? This is the type of problem where realistically they could also give you or not give you the answer choices. So I want you to be able to solve it kind of like classic math style as well, okay? Here it says, which of the following is an equation of a circle? The moment they give you this, I am leaning on this equation, okay? X minus h squared plus y minus k squared is going to equal r squared. The moment they give me this. And the h and the k will represent my center of the circle. The center coordinates of what my circle is going to be. The r is going to represent my radius. I'm actually get rid of this, put this box down to the side so it's a little bit neater. Makes it easier to write. And now, many of you remember that the radius of the circle is simply the center of the circle to like an endpoint of the circle. So it will look like this, right? That would be considered the radius, but the radius could also be this one, right? Over here, the radius could be here, right? So that's, all those are referred to as the radius, right? The diameter is when I cut exactly across the circle, right? Where I just connect two equivalent radii on both sides. And here, it says, which of the following is an equation of a circle in the xy plane with a center of 0,4? The moment they give me the center, I can plug in these values. So that's always a helpful, right, hint that you're going to want to be aware of. And then it says a radius of this. So, and a radius with endpoints. So notice they don't give you the radius, all right? Here's what they give you. They give you a point on the circle, and they give you the center of the circle. Right? The first thing you should do is solve the center of the circle because that's the easiest thing to do. So you just want to plug in 0 is going to be your h in this case because that's your x, and 4 is going to be my k, right? For what they correspond to. So if I plug them in here, and I'll get rid of this, let's make this smaller so I don't take so much off next time. And okay, so here's this, and it's x minus 0, and then plus y minus 4. Now I'm going to simplify this a little bit. This is x minus 0 becomes x, which becomes x squared. So these all have x squared. Okay, that doesn't really help too much. And this becomes y minus 4 squared. So anything with a y plus 4 is gone. Okay, so now if you just know one step, you're 50-50. All right, now the question is, why are they giving you the endpoint here? Now, you could theoretically plug in the endpoints as being my x and my y, right? I could plug these in as being x for my 4/3 and my y for being my 5. But I'm also going to solve this classic math-wise, like I said, because let's pretend they don't give it to you here, right? You don't have it like set up, okay? Now, if I do this, right, here's a center and here's an endpoint, then here's what I notice. Is if my center and endpoint are both given to me, what I actually have between them is a distance, okay? So my distance between my radius and my endpoint can be determined by the distance formula. So here, basically in a nutshell, here's what I have, right? And I can figure out the distance between the endpoint to the radius by doing this, okay? So I basically have like 2 points on the circle. And I can determine what this is, right? And if I can determine the distance between the center and an endpoint, then check that out. I have the radius, right? So the question is, all right, well, if I'm doing this, then what do I use in order to figure out the distance between 2 points? And the answer is your distance formula. So if I want to figure out what is the distance between 2 points, this is actually going to equal the radical, and it's going to be x2 minus x1 squared, and then plus, I'm going to do y2 minus y1, and then squared, right? So the thing is, I want to choose points that sort of work. So as long as I choose whichever these is the 1 and whichever is the 2, it's fairly easy to get them mixed up. But I want to make sure that whatever points I choose are corresponding for both, right? Like what's the 1 and what's the 2? And just from reading it left to right, I'm going to choose the center as my 1s, and I'm going to choose the endpoints as my 2s, right? As I'm like reading to the other side, all right? So if I do, this is from practice test 1, for those of you that are just joining us. And quick reminder, do your best to kind of post the questions inside of the chat function so I can kind of answer them live so that you guys have it. Otherwise, I have to sort of click out and it takes a little bit more time. Not the end of the world, but just so I can kind of answer them when done. So we're in practice test 1. We're on number 24 right now, right, for section 4. So here's what I say. I'm going to label these. I'm going to make this x1. I'm going to make this y1. I'm going to make this x2, and I'm going to make this y2. And now I'm just going to plug in these values here. So I'm going to bring this down. This becomes d and radical, and my x1 is 0, and my x2 is 4/3. So I'm going to make this 4/3 minus 0, and then squared, and then plus my y2 is 4. And no, my y2 is 5. Okay, and then minus 4, cool, is 1, and then squared. All right, so then here's what I get. I get this whole thing here, right? So the distance is going to equal radical still. I'm going to get 4/3 squared plus 1 squared. And I'm going to get rid of this, right, using my distance formula. So that I can simplify a little bit more. You guys see where I'm going. And so once again, I'm purposely doing it this way so that way you can see the math behind it in terms of like how I'm setting it up with the equation of a circle relating to distance formula if you do get this type of question. So right now what I have is my distance is going to equal, now remember that whenever you have something like with a square root, or not a square root, with an exponent on the outside, remember this goes to both, right? So it becomes 4 squared and 3 squared, right? So this is actually going to become 16/9. All of this is still under the radical, by the way, and then plus 1. Now, okay, so this just becomes as hard as adding fractions together, which tells me that one of these, okay, so these are 9s and these are 3s. Notice what I'm doing. I'm going back and I'm looking at my answer choice to sort of justify, okay, am I on the right path? Does this make sense? Like problem solving wise, can I do this? And if I want to add these together, then I have to make the 1 here, I have to make them both a 9, right? I have to find the common denominator between them. And this becomes then d equals 25/9 radical. So I'm leaning towards the fact that it's going to be c, right? If I simplify these two expressions. Here's the problem with that though, that this here is actually my r, right? But in my equation of the circle, if I write it down again, so one thing that this does tell me is that I definitely did it the right way, right? My answers are 25/9 and 5/3. So one of these is definitely going to be my answer. But what I don't probably want to do is make the common mistake of forgetting that my equation of a circle, which looks like this, right? Y minus k squared equals r squared. What I don't want to do is forget this part here, right? This is r squared, not just r. I solved for r by figuring out the distance between both points, which is this is r, right? So my r here is equal to radical 25/9. That's what that is. But I want to square this in order to put it back into my equation of a circle, right? It's a common misconception. It's probably a common thing a lot of students will probably get wrong when you're not sort of plugging in your equation of a circle. So one tip I would give you is to lay out the equation of a circle, right? Start crossing things off that don't make sense, that you can eliminate them, like when you determine your center, but you should still have your equation of a circle like somewhere visible to you as you write it down, so you know that you don't make like a common error as you're solving it through. And this is r squared. So if that's r squared, then what happens here is that I have to square this, right? So if I know that if r equals my radical 25/9, right, or radical, sorry, like this, then if I want to square this, I have to square all of this like that, right? So if I square my r, I square the whole radical, which means the radical goes away. And if the radical goes away, then a will be my answer, right? If I've actually plugged, this will actually be my r squared, right? So r squared is 25 over 9. R, because it's the distance, and my determining the distance formula was radical 25 over 9. So by plugging that in, it makes it a lot easier, and I simply check, right, for what we're doing. So I hope you sort of got a lot out of, I would say, like the hardest problem some would consider for SAT practice test 1. And a lot of you guys had asked, because we've done a number of problems for practice test 1 in the past, that, hey, can we break down some more of the problem? So what we're going to do is we're going to move into the SAT reading section. Okay, so if you have any particular questions at all regarding the math that we covered, or even maybe you have some other tips or suggestions or other types of practice problems that you might want to cover, don't be a stranger. You're more than welcome to send me kind of a quick email, and I'll post my email again inside of the chat boards. That way you guys have it. I will also say that for whatever particular reason, if you feel like comfortable now, and maybe for instance, you're going to be like signing off in a little bit, we do have upcoming seminars as well. And before you go, kind of want to quickly give you those, because many of you are asking. So we have an upcoming ACT science webinar that will be tomorrow. Some of you had recommended it, and if maybe we can cover other topics. So I'm posting both of those Zoom links there for you. Both are free, right? You're more than welcome to. The ACT science webinar is being led by one of our like ACT science gurus. The amount of students that have worked with him and got a perfect score, so the list goes on in terms of ACT science. So if you're debating, hey, maybe I want to do ACT science or ACT versus SAT, I would say one of the biggest differences between the tests are the timing per section, the timing per problem. The ACT is significantly faster. I would say the complexity of the questions, the SAT is more complex, but they give you more time. And then finally, the science section. So we wanted to purposely do the science section rather than just jumping right into the math or the English for the ACT, because a lot of you guys are debating, hey, maybe I want to do the ACT science, or maybe I want to do the SAT. My advice would be, you probably want to practice at least to take both, because there's a lot of content that's so similar across both tests. But if you feel as though you're pretty good with the ACT science section, then it no longer becomes like a hindrance for you, and you don't become overwhelmed by it. And if anything, it strengthens your overall ACT score. So if you have questions regarding the ACT or the SAT, you're always welcome to reach out. But I would definitely encourage you, if you were contemplating at all of doing the ACT, you probably want to tune in tomorrow, because tomorrow, Mr. Jason Lamarca is going to be walking you through sort of how to approach the ACT science section in particular, and that way it will kind of hopefully help alleviate some of your concerns about what to do and some major strategies that are involved. And then finally, back again on Tuesday, I will be leading you through an ACT or an SAT English passage, because many of you have already requested that. And you said, hey, we've done a lot of math, we've done tons of practice problems thus far. Can you maybe show us sort of like how to break down the SAT English section? So not a problem at all. All right, so we're going to get ready to move on and do the reading passage. So what I would recommend for you, and we're going to stay in the same practice test. And I would also recommend for those of you that have done the practice test 1 in the past, and sort of just kind of like examine a little bit, see if maybe there's things that you can take out of it as we work through. So we're on the same practice test that we've been using. I'm going to slide back, and I'm going to do SAT practice test 1, section 1, right? That's the reading section. Now, I'm not going to tell you all the ins and outs of what the reading is, right? We're sort of going to skip over that. Instead, I'm going to tell you how to approach it. So I'm going to save some time and go right to the strategies of like what to do, okay? All the nitty gritty, kind of what it is and what passages and how much time you get per thing. Like, you're more than welcome to read that within your book, right? To kind of maximize your time, I'm going to tell you essentially what I would do and how to approach an SAT passage. And I'll write a few things down so you can kind of make sense of it, so the way it makes sense. But at the same time, as we're going through, because there's going to be a lot less writing on the screen, what I would suggest to you is just simply ask questions throughout, okay? If you need it for whatever particular reason. Okay, so here's step number one, right? For when you first come to an SAT reading section, the first thing you kind of need to very quickly understand is that for the reading section, they do not assume you to have outside knowledge. Okay, I kind of have to make that fairly clear, is that they assume you to have outside knowledge, but not like in the context of whatever it is that you're looking at. So they do, in this instance, they do not assume that you know biochemistry, right? They assume that you might have heard of it, maybe taken a biochemistry class or biology or chemistry or something, but they're not going to look down here and assume you know Chargaff's principles of connection, or that you studied like Rosalind Franklin or DNA, all those other sorts of things, right? They're not going to expect you to know those things. What they are going to expect you to be able to do, and really what SAT reading is doing, is can you interpret and read an analytical piece of information and then answer questions according to that information. That's really the end all be all, right? You might find the passages uniquely boring, right? You might like it because it's something that you do and like you're interested in. What I will say to you is that they're purposely picking pieces of knowledge that require like an in-depth level of reading. So they're not going to choose something that is like BuzzFeed, right? That's not, and life doesn't do that anyway, by the way. Like like if you have to learn, taxation or tax law, or maybe you go on to become like a doctor or something, that's not everything is going to be sort of like that type of reading. You're going to actually have to like go into more of like an analytical reading of approach. And that's really what the SAT will focus on. I would actually say probably the closest thing to it is more of like screenplays of some sort, like you're trying to identify characters or placement or setting, or you're putting a lot of thought into it as you're reading those things. So on that note, here's what you do, okay? In a quick nutshell. What will happen is you want to read the blurb in the very beginning, right? And the blurb is just to give you the general gist. So the thing I want to read here, right? And also to kind of quickly note, there are different strategies for the SAT reading. The strategy that works best for you is depending on how fast of a reader you are, all right? Now I'm going to tell you the strategy that generally works best for most of our students, but bear in mind that you might find your own rhythm to things, which is actually what I encourage you to do. If you've been practicing with us for quite some time, you'll understand essentially what I'm talking about. Like you'll do enough practice problems where you kind of understand enough practice passages where it makes more sense to you by doing it a certain way. So here's the first thing you want to do. Step one, you want to read a little blurb, right? You're trying to understand what the main idea is, or the theme essentially within this. And if you can target the main idea or the theme, it makes it a lot easier overall. And I want to underline maybe some things that I take out of the title or the theme. And it says here, the passage is adapted from J.D. Watson and Crick, Genetical Implications of the Structure of DNA. If you can't pronounce a word as well, don't even worry about it. Okay, so this is just genetical structure of DNA is what the passage is going to be about. And then it says, right, okay, so DNA evidence using Rosalind Franklin and X-ray crystallography, diagrams of DNA, and Erwin Chargaff's data on this. So this is basically how DNA is made, right? That's what I'm about to read. I'm about to read some sort of piece of information referring to how DNA is going to be constructed. Now, I can read the first few sentences here if I want to, just to kind of break it down. But I'm actually not going to do that. And instead, what I'm going to do is I'm going to skip right to the questions. And the reason I'm going to skip to the questions, just so you're aware, is because I have enough kind of confidence in being able to read the question and break down what I need from the question in order to do this. Now, in the beginning, you probably also want to circle the things in the question that matter to you, right? You want to kind of and I would strongly suggest you do this. You need to annotate the questions. And what I mean by annotate is you need to circle the words that matter when you're trying to answer the question. And you need to be able to basically paraphrase. You need to be able to paraphrase what it is that the question is asking you to do, okay? Here it says the authors use the word backbone, circle that in lines 3. So I really care about lines 1 through 5, and 39. So I care about lines 38, 39, and 40 to indicate that this means, like, what's the purpose, right? That's what it's trying to do. I'll also give you a quick tip. The first questions, like the first few ones, excuse me, are usually more broad. And when these types of questions are broad, I probably would skip these. I would go and get other questions first, so that way I have more information to answer something that's probably more related to the main idea, all right? Now, just as a quick tip. Now, this question I feel like I can answer because it's kind of specific enough, but if you ever run into like I don't know if I can answer this question yet, that's purposeful. Like whenever they give you something like, hey, what is the main idea? Or what is, oh, the one they always use, the love is, what is the developmental pattern of the passage? What's the theme of the passage? All of these, if you get one of these in questions like 1, 2, or 3, just you usually immediately want to move on because you need to understand more about the passage. You need to get more context out of it. So instead, what I would say is that because these are probably more line specific, I'm going to try to answer this as best as I can, right? I'm going to try to answer it as best as I can. But if they ever mention something like, hey, what's the main idea? What's the developmental pattern? What's the structure? What's the theme? That means it's about the entire passage, and I have to basically like watch the entire movie so I can answer that question, right? That's the idea. I can't answer that immediately yet. But I'm going to still walk you through my thought process of like how I answer this. So I'm going to get rid of these. And actually, I'll rewrite it again if I need to. And then, okay, so the authors use the word backbone in this. So I want to go back to the lines of what they give me. And I'm going to read, like I said, numbers 1 through 5. And I'm purposely going to circle the word backbone here. And I'm trying to look for tone, and I'm trying to look for context. That's what I'm trying to figure out. Tone is like the emotional, the emotional well-being of the passage. So the biggest question that we always get actually is something that one of the students just posed, which is, do you recommend us to read the questions before we start reading the passage? You want to basically find your rhythm. What I definitely recommend you to do is you need to read at least the question before you go to the passage, because you need to know what you're looking for. It's almost like kind of like a scavenger hunt. You do not need to read every question before you get to the passages. You will learn what you can answer and what you can't answer based on practice. Basically, you will learn questions that are easier to answer first versus trying to answer every single question. But 9 out of 10 times, you will almost always use the questions as a guide in some way, right? 9 out of 10 times, you will almost always use that question or a series of questions as a guide of kind of like what to look for. Because it just saves you time, essentially. And also, it's the same strategy for the ACT, for those of you that are, once again, considering. All right, so here it says, the chemical formula of DNA is now well established. The molecule is a very long chain, backbone. All right, now here's the thing. I kind of skipped a step. And that is, when I am reading a question, okay, what I want to do, and this is huge, okay, is that when I get to a question and I read the question and I paraphrase my question, which means I know and I circle the things that I need. What I want to do is I want to think of synonyms of how they'll describe the evidence. Okay, they'll describe the evidence. The evidence is the text. That's what I'm referring to. All of your answers are there, right? All of your answers are inside of the text. But this is the biggest thing. If your vocab is fairly strong, the SAT is actually like a walk in the park. And that's because you don't read something and look it over not knowing that it's a clue, right? You look at it and you know it's a clue, so you basically pay attention to what to look for. So this is to tell you, hey, this is what I should be looking for. This is to remind you quickly, okay, before I go looking for these things that are related to this question, I need to remind myself that they are asking, how is the word backbone used? So I want to find adjectives that are related to backbone, right? That's the idea. So how is the word backbone being used? And I want to find like descriptive terms or describers, right? How is it being described, right? So find adjectives that relate to that. So I do that relatively quickly. It was almost kind of like autopilot, which is my bad. I do that relatively quickly so I can basically go back to the text and I know, and I try to figure out like quickly, like, okay, well, how's it going to be used, all right? So here, the chemical formula of DNA is now well established. A molecule is a very long chain. Notice here what they're doing. They say very long chain. The backbone of it consists of regular alternation. That's a describer, it's a term of sugar and phosphate. Okay, so regular alternation, sugar and phosphate, very long chain. They use the word molecule. Okay. Now I'm going to read a little bit more for a little bit more context so I can gather more from the passage. It says, to each sugar is attached a nitrogenous base, which can be of 4 different types. 2 of the possible bases, adenine, guanine, and purine, and the other 2 are thymine and cytosine. So I'm going to underline these because this is like a condition as well. This is what they're telling me what they are. And it says our pyrimidine so far is known, sequence of bases along the chains are regular. Notice what I did. If I didn't think I had enough information, what do? You keep reading. You keep reading so that way you feel as though you have enough of a context of what it is. If you feel like you have to read too much to answer that question, that's up to you. You have to get in the habit of knowing, and it only comes with practice, to be fair. I can't give you, hey, this is exactly how much you need to read, because you need to understand the format of the questions. You need to get into the rhythm of what the questions actually are. I can tell you I have enough information now based off of this section to answer what I think to be the question anyway. So I'm also going to scroll down and I'm going to compare, right? Because they want to know these lines here. The phosphate sugar backbone, notice here they mentioned phosphate and sugar again, backbone of our model. So now they're calling it a model. Before they refer to it as a molecule. Notice the title said structure, right? Those are all things that I'm kind of thinking about. Is a completely regular, but any sequence of the pairs bases can fit into the structure. It follows that in and then sliding up. Okay, long molecule, they mentioned very long, many different permutations are possible. Permutations is a fancy word for variations or possible combinations. That's what permutations is. Okay, so I have all this information now, right? And I'm gonna go down to my answer choices. And now here's the other step. So I paraphrased in the beginning. Okay. I found my evidence, Notice I'm trying to like walk you through like a basic strategy, right? I found my evidence using, I would say, synonymous terms, right? Or synonyms of like what to look for. So I knew like what to pay attention to. And now here's the $1 million thing. I want to develop my own answer choice. Now, if you do this and if you get good at it, you're set, right? Things get a lot easier. And I'm going to do this every single time, right? I'm going to paraphrase, I'm going to annotate the question, I'm going to find the evidence using synonyms of I think what they're asking for. I'm going to develop my answer choice. Now, I'm going to develop my answer choice using my own synonyms. That's why I'm saying vocab is so essential, right? So develop my answer using what I think that they're going to use or what I think that they're going to say using synonyms, okay? And then finally, I'm gonna do this. I'm gonna use process elimination, but I'm also going to kind of subset this. I'm going to watch for traps. So before I answer this question, I'm going to tell you like what the most common traps are, right? So let's say SAT reading, and I'm going to say just traps, like common incorrect answer choices, okay? And there's not a lot, so it'll be really quickly. The first is it's not even mentioned, right? And we call that out of scope, right? So it's off topic in some way. So if the thing isn't even mentioned, it's probably not your answer choice, okay? Or off topic, the easy way to remember that. The most popular answer choice, the most popular incorrect answer choice are what I would refer to as extreme words. So you have to pay attention to if the words are saying like always, only, never, right, entirely. What happens here is that if everything might be right in the sentence, except for the fact that that one word will make the rest of the sentence incorrect, right? So that's why you want to pay attention to if they're using extreme words, absolutely, entirely, never, only, always. Those are conditional statements, and 9 out of 10 times they will not be the correct answer choice because they will kind of lock the answer in where it's not broad enough, and then it will therefore make it incorrect, right? It's not vague enough or not broad enough. And then finally, probably the most other common incorrect answer I would say are opposites, where it is right, but it's the wrong condition, right? So they'll give you something where it's the up, not the down, right? So pay attention to these three common, right? And I'll even keep these up here for the time being. So here we go. The authors use the word backbone and line. So here's my answer before I read, because I don't want to read A, B, C, and D without knowing what essentially I should be looking for. The word backbone is being used to describe the structure of DNA with phosphate and sugar, right? It's describing how it's going to be built, right? In some way. And they use the word model, structure, design, right? All those other things. So I'm thinking about that before I read this. And I want to try to avoid extreme words or attractors, and I'm going to try to avoid things that aren't even mentioned at all. All right, so here it goes. This immediately I don't like. Only very long chains of DNA can be taken from an organism with spinal column. There's nothing mentioned about spinal column, so I'm probably not leaning towards A. Now notice what I'm going to do. Every single answer choice, I'm going to justify, or I'm going to sort of like put a mark next to, because either I like it or it's not as good as the other answer, so I'm getting rid of it, right? So this is what I mean by cross-elimination. So it's like an intense, like analytical, what about this works, what about this doesn't work, let's get rid of it. The main structure of a chain of DNA molecules is composed of repeating units. This does work, right? Because it says a main structure and it says a repeating units, which is what they refer to, if you remember, as, if you have to go back and read it, totally cool. But that's what they refer to as regular alternation. Regular alternation means it's the same sequence, okay? So let's go. So I like B, but I'm not done. I'm still gonna read C and D, right? So I'm gonna slide this up a little bit. There we go. Okay, so I like B, but I'm still gonna read C. A chain in DNA molecule consists entirely of phosphate groups and sugars. Well, I know that's not true because I kept reading before, and it also consists of nitrogenous bases. So C is really nice. C is good. C is like a chain in DNA consists entirely of this. So I would venture most students would probably pick C because phosphate and sugar are mentioned in both of those lines. However, this word here is a huge trap. And I know that it also consists of like nitrogenous bases. So it's probably not going to be C. D is nitrogenous bases form the main structural unit of DNA. Well, that's not what backbone's referring to. Backbone's referring to phosphate and sugar. It's not referring to nitrogenous bases. So I like B the best, right? B is probably what I'm going to choose. And I'm probably going to avoid choosing C because of the fact that I know more information is for nitrogenous bases, right? What happens if I'm between B and C? Go and read more, right? Read a little bit more, get those lines to understand the DNA also consists of the nitrogenous bases, and it's not entirely, right? It does consist mostly of phosphate and sugar, but the nitrogenous bases are acting as a huge part. So see what I did? You read the question, you paraphrase it, you go and you think about how the evidence is going to be worded. You then develop your own sort of synonyms of what and how it's going to be worded. I go and I find the evidence, I read it, I then create my own answer choice, then come back, and then I answer the question. It's very like systematic. It's not necessarily like I'm reading an entire story, and sort of I'm approaching this very systematically so that way I have enough time to get through as many questions as possible, right? All right, so I'll do the same for the next question so you guys can see it. And I'm gonna get rid of this, okay? Now, granted, the first question always takes like the longest because I sort of have to show you what the model is, but the questions moving forward, it kind of should, I'm hoping you're kind of paying attention and you're sort of seeing like how to think about this. So it makes a little bit more sense. Here it says the student claims a nitrogenous base pairs randomly with one another. I start with the word randomly because it's a condition or describer. This says nitrogenous base pairs randomly. Which of the following statements in the contradicts the student's claim? So contradicts means they're not random. That's what it basically means. It means not random. So I need to find evidence that supports the fact that they are not random. So what are words that mean not random? Okay, so words that I should probably pay attention to: order, sequence, not random. Let's see, what are the organized, right? So I want to think about words that mean that, so I know what to look for before I start reading the evidence. Now I'm going to go and read lines, 5 and 6. So I'm also going to read purposely a little bit before and a little bit after. Hope you guys are getting something out of this, right? So I'm going to read a little bit before, which is okay, so in the phosphate groups, each sugar is attached on nitrogenous base, which can be 4 different types. 2 of the possible bases, adenine, guanine, and purines, and the other 2 thymine guanines are pyrimidines. So this doesn't answer the question. Okay, so far as known, the sequence bases along the chain is irregular. That doesn't answer the question. It gives me information, which is vital to maybe understanding other questions, but it doesn't answer this question for what I'm going to need, right? So I don't like A, so I'm probably going to mark that off. You with me? So every single time I'm like ticking away, like don't like you as much. So I'm gonna go to the next one. So the next one says 9 through 10. So I'm gonna go 9 through 10. And 9, so far as known, the sequence of bases along the chain is irregular. The monomer unit consisting of phosphate, sugar, and base is known as a nucleotide. Also doesn't answer the question. Don't like that as well. So could have ticked that one off. Right? Notice it's back and forth, right, the entire time. So let's get rid of that guy. So lines 23 through 25, and 23 is, now one quick tip I will give you is that if your answer goes a little bit before, you want to read to the sentence, like don't just start in the middle of the sentence, start before the sentence comes, or if it tells you to stop, like read to the end of the sentence, right? So read the entire sentence to understand context of what it is they're actually talking about. So the other biologically important feature is the manner in which the 2 chains are held together. This is done by hydrogen bonds between the bases. The bases are joined together in pairs, a single base from one chain being hydrogen bonded to a single base from the other chain. This might be the answer, perhaps not. The important point is that only certain pairs of bases will fit into the structure. Okay, so maybe that, perhaps. And then it says one member of a chain must be a purine. Well, okay, so that is my answer, right? This is good. One member of a member must be a purine and the other a pyrimidine in order to bridge between the 2 chains. Now, the reason I like this is the word must be. It tells me there is an order, right? There's a structure to it of how it comes together. Now, I want to go back to my answers to see which line was this. And one member of a pair must be. Okay, so I'm going to go down. And one member, yeah, so my answer is probably going to be D over C, right? So I'm purposely picking where the best answer is and like what goes with the main idea the best. So I like D here, I like B here, right, for this one. And this one is because of the word must be, right? The terminology, right? I like my evidence for must be there the best. Now, here's what I did. Read the question, deciphered the specific language out of the question that they needed. Specifically, I deciphered the fact that it says contradicts, and it says this is random. So what is opposite of random? Not random. What means not random? Ordered, sequence, arranged, right? Something has to mean not random. Why did I tell myself those things before I read it? Because I needed to know if it was a clue or not. That was the idea. I can't just read it just assuming that it's going to pop up. I need to know what I'm looking for in advance. And if I know what I'm looking for, then all this becomes so much easier as I work through. All right. In the second paragraph, lines 12 through 19, what do the authors claim to be a feature of biological interest? So I can go and I can read this particular question because it says lines 12 through 19. And here I have 12. The first feature of our structure, which is biological interest, is that it's not of one chain, but of 2. It perhaps could be that easy. Seems these 2 chains are both coiled around a common fiber axis. It's commonly been assumed that since there was only one chain in the chemical formula, there would be, okay, so the word assumed means it's incorrect, right? There would only be one in the structural unit. However, right, there's not one chain. The density taken with the X-ray evidence suggests very strongly that there are 2. All right, so there's definitely 2 chains. That's the theme of this paragraph, and it's also suggesting that they have evidence to support the fact that there's 2 chains. All right, so my answer should be that there's more than one chain, right? That there's multiple chains, that there's 2 chains, that there's something, right? That's what I'm trying to find. So in the second paragraph, like, what do the author's claims be featured? Well, the feature is not the evidence. The feature is that it's multiple chains, right? So 24 is going to be D. Now, if I go to 25, 25 is the author's main purpose of including the information about the X-ray evidence. So the main purpose here is what is accomplished, right? What is accomplished inside of the passage? Like why offer that piece of information, right? That's the real trick of it. So the reason why they're offering that piece of information, what is going on? The reason why they're offering that piece of information is to tell you that it's more than one chain. That's the reason why. They're trying to tell you that it's more than one chain within it. So my answer should justify that there's more than one chain. I just found the evidence, right? I did it through. And here it says the author established the DNA is the molecule that carries genetic information. That's not mentioned, not in that particular part anyway. So I'm not leaning towards A. Present an alternative hypothesis about the composition of nucleotide, also not necessarily mentioned. Provide support in the author's claim about the number of chains. This hits it. And so provide support means evidence, right? So that's the reason what they're saying. Confirm the relationship between the density of DNA and the known carbon. No, let's see, right? So C is the only one that is supported by the evidence of what they're telling. Now I'm gonna kind of quickly see here. There's a few questions, right? Once again, chat function, hit the chat, put it in there. I believe in you. You can do that, right? Do you recommend us to read the questions before we read? For a question like number 23, we already found that, for example, works. Should we still check these here? Yes, always check it. And okay, so here's the reason why you always want to do your best to check every answer choice. The sad truth is the SAT sets it up so there are different possible answer choices where like you can justify one, maybe two answers, and they kind of want to put you in that position, right? So you have to find the evidence that's best correlated to the main idea. So yes, always read every answer choice. Here's the other truth about it, is that the SAT, these questions are, these answers are generated from like multiple questions, all right? So in order for you to get good and maximize taking the test, what I would suggest for you to do is as you're going through every single practice problem is, I can do any practice test, any reading passages, it's all the same, right? It's all the same process of how you go about solving the questions. So what I would suggest for you to do is every single time you're answering practice questions, you need to be able to justify whether the answer is right or wrong. Not just, so you have to look down at that answer and say, why is A not right? Why is B not right? Why is C right? Right? Why is D not right? Because all they have to do is change the terminology up here a little bit, and then suddenly A becomes better, or B becomes better, or something of that instance. So you always have, as you're reading answer choices, you need to like critically evaluate. And as you're practicing, you really want to critically evaluate why some answer choices are better than others. And the moment you get in the habit of doing that, the better off you'll be of taking the actual test. There isn't going to be something that's going to like sort of slip you up or confuse you. So I would say as you're practicing, make sure that you're reading every answer choice, and most importantly, justify why some answers are better than others. That is the end all be all that I would essentially tell you. I'm going to slide down and do number 27, and then I'm going to skip forward and I'm going to do some other problems that are like a little bit more of a connector so you guys can see it, or like two together, and I'll do some graph problems as well and like kind of walk you through. So I'm going to do 27 here. And 27 is more of like a line-based and an evidence question. And here it says the authors use the words exact, specific, and complement. So exact, specific, and complement in lines 47 through 49 in the final paragraph. Now, notice it says functions mainly to. The word functions mainly to is like, what purpose does it serve, right? Like, why do they end up doing that? And a quick tip I'll give you, and a lot of students actually get this wrong, but it's not really that difficult of a problem. But the reason why you get it wrong is because you stop reading. So notice here it says 47 through 49, and they want to know, why do you use exact, specific, and complement? What's the purpose of the authors to do that? So when I go up here and I read 47 through 49, here's what I get. I get 47, which is like in the middle of a sentence, right? So I want to start up here, right? It's my first thing. I want to start above, right? To where it says if the actual order of the bases on one pair of chains were given, one could write down the exact order of bases on the other one. Because of specific pairing, thus one chain is, as it were, the complement. Notice what I'm doing. I'm circling the words that matter, or I'm underlining them. And it is this feature which suggests how the DNA might duplicate itself. So this feature here is what might duplicate it. So if you stop reading at 49, then you make the, right where the comma is, you make the mistake of not figuring out where this sentence is going. So a quick tip I will give you is read the entire sentence. Don't just read the exact part that they tell you. Instead, branch it out a little bit more and read the entire sentence. So this all is like 2 sentences here, right? But I'm going to read a little bit before so I understand the context, and I'm going to read the entire sentence here. And my answer of why they're telling me that it can write down the exact order of the bases and form another chain, and that's why they say specific complement and it's a feature, is because it can duplicate itself. That's the idea. So what words mean duplicate, right? So I want to duplicate itself, right? That's the whole purpose of it. So I would think like recipe, copy, template, what are other words that like sort of simple? Mimic, mirror, right? See what I'm doing? I'm just coming up with words, because what I need to know is if I'm reading an answer, I need to know if that's an answer. That's the other idea. I can't just get suckered into evidence. I also have to know basically what I'm reading and like what for. So as I read down, and if I go into my answer choices for 27 here, and let's get rid of this. Okay, so here we are. It says the authors use these words for what reason? Confirm that the nucleotide sequences are known. I mean, perhaps, but that doesn't answer, right? That none of those things talk about duplicate, copy, template, right? None of those things mention that. So I'm probably not going to be big. Counter the claim that sequences of bases along a chain can occur in any order. Well, this is true, right? And someone mentioned earlier, hey, why do we read every answer choice? Because this is possible. Like technically it does counter the claim that they're not in random order, right? And that goes back to our previous. However, I'll keep this for the time being, but I can tell you that that's probably not going to be the best answer. Support the claim that the phosphate sugar backbone of the author's model is completely regular. I don't think it really answers this. Emphasize how one chain of DNA may serve as a template to be copied during DNA replication. There it is. Boom. 3 all. Man. May serve as. That's the purpose. Gone. Right? So I'm evaluating between every single answer choice every time. That way it makes a little bit more sense kind of as we're working through it. So let's do a graphing question now, kind of like breaking it down a little bit, and some strategies that you guys might have regarding some of the graphing. So I'll say this, out of the questions we've covered thus far, let me know. Feel free to comment in the sections if this makes sense for you, if you have any general questions in terms of tips. I can tell you that the only way you're going to get really better at this is doing it and learning how to think about it as you do it. That's first and foremost, because a lot of these, and I'm writing a lot, and we're 34 minutes in, and we've only done 6 questions, but this should be, it should be like a rhythm by the time you actually get to it, knowing what to do, how to set it up, sort of what to look for, almost like you're like reading a defense, right? It may be the best analogy I can give you. So let's do this. Let's go based on the table and the passage. Which choice gives you the correct percentages of the purines in yeast DNA? So here's the first thing I want to note is whenever they give you this terminology based on the table and the passage, the moment they say this table, it means that the passage will have like definitions, or they'll have some sort of condition that they're going to give you. And it's things you have to be aware of, right? And then the next is when they say table, it means I have to match that condition to whatever it is inside of the table. I have to figure out what the pattern is in the table, okay? And then it says correct percentages of purines in yeast DNA. So this is what I have to find, right? This is the thing I'm trying to solve for, okay? This is how I think about it for matching the pattern, definitions, and what to do inside of the passage. And this is what I actually have to answer. So I care about purines and I care about yeast DNA. Okay? So I'm going to slide back up. And odds are the table will not give me everything I need. And how do I know that? Because they said the word passage. Okay? So that's something that you have to be aware of. And if I go to the table, a quick way to break down any table, okay? Any table, quick way to break it down. 1, go right at the title. 2, go at the little description. 3, go at the columns, right? And if they don't have columns, like if it's a figure, go at the axis. Go at the X, go at the Y, right? Figure out what it is that they're telling you in both of those, because that will quickly kind of break it down for you. And you do those 3 things first before you go fishing. And if you can break it down, then you generally understand what the table's about, like relatively quickly. All right, so the table shows the various organisms, the percentage of each of the 4 types of nitrogen spaces in the organism's DNA. So I know nitrogen spaces are part of DNA. I know that they're made up of nucleotides. I know it's structured, right? It's not random. I can go and read the rest of this if I want to before I get to these questions, or whatever helps you the most. This is my organisms. These are adenine, guanine, cytosine, thymine. All right, now here's the thing. Here's the takeaway. The question asks for purines, right? Specifically, I'm scanning pretty hard here. I don't see the word purine anywhere. So that's the reason why they're giving you the passage, because they want me to figure out where the purines are. They want me to figure out what the actual purines are, and that's how I connect the passage to the table, okay? So I need to figure out what the purines are in order to answer the questions within the table. So I'm gonna first go to get rid of this, okay? And here we go. And I'm gonna skim for the word purine, and you'll get good at this, right? As you've already read, right? Maybe you mark it down also as you go through. So 2 of the possible bases, adenine, guanine, are purines, boom, done. Adenine, guanine, these are my purines. So I don't even care about cytosine or thymine, right? In this instance, I might care about them in future questions, don't care about them in this question. And then I need to know yeast DNA, okay? So I'm not focusing on the rest, I'm only focusing on yeast. So these are really what I care about, all right? So it wants to know, and let me just summarize, and I'm answering the question that they're actually asking. It says, based on the table, which choice gives the correct percentages of the purines in the yeast DNA? So it wants to know what are the percentages of yeast DNA purines, so adenine and guanine. Well, if I slide back up, it's 31.3 and 18.7. That's my answer. 31.3 and 18.7 are my yeast DNA purines for adenine and guanine, and thymine and cytosine are my pyrimidines. So if they just simply change the question, right, I have to understand why maybe they're getting that answer choice. Notice one word and suddenly I have a different answer. That's the idea. So I'm going to slide down, and I have 18.7 and 31.3, and C is my answer choice. And I'm done, right? You should sometimes be able to like figure out though, where are they getting the other answers from? If you can kind of decipher that, then you understand why it might be an incorrect answer and why they might purposely try to set you up in that way. So here, general question that some of you guys are asking, will the questions on the SAT require previous knowledge about the questions of the passage? No, but they will assume that you, so here's the assumption that the SAT will have. They will assume that you have taken high school biology, high school chemistry, and some level of high school physics, usually like conceptual. I can give you a list of the most common equations or most common things that you'll generally need for the SAT or for the ACT, like outside knowledge, but everything that you will need to actually answer questions and for in terms of evidence, they will provide to you inside of the passage. Sometimes it's better to be fair. Like I've done biochemistry before and I majored in it. I know this passage inside and out. I know where it could go. I know other ways it could go. Sometimes that's bad though, because you might know like so much of the outside information that it can actually trip you up. So you want to sort of stay focused on just what the passage is providing you in that context. And remember to develop your own synonyms as you're going through and you're answering kind of questions throughout. That's the biggest advice that I would give to you, is stay focused on what the passage is giving you and not try to think about everything you've ever learned, you know, regarding maybe are there certain species that like this doesn't correspond to. Don't worry about RNA and DNA in this case. Like they don't care about, you know, everything else. They just want to stay focused on that particular passage for what you need to do. I will say that happens a lot when you get to a work like a historical piece of fiction. and you're thinking to yourself, oh, wow, I've read this book before. Like, this is great. You're like, wow, Virginia Woolf, or I've read Don Quixote or something. But I would strongly recommend just stay focused on what the passage is and what the actual main idea of the passage is. Try not to think about too many things outside of it, because then it might distract you from what the question's actually asking. All right. So here we go. Let's go to 29, which is really kind of substantial question, right? It says, do the data in the table support the author's proposed pairings of bases? Now, this is under the assumption that I know what the pairing of the bases are, right? So this is within the passage somewhere, right, of where the pairing of the bases are. And I've read majority of the passage at this point, so I should have an understanding. It also says, does the data in the table support? Which means I will, once again, have to match the passage conditions to what is inside of the table, right? I have to somehow figure this out first, okay? And I'm gonna go to the passage, and I'm gonna read like relatively quickly, so that way we can see it. And I know that it's not in this paragraph because we've already read it, and technically I've already read down here. It says, the other biological feature important in the manner in which the two chains are held together. This is done by hydrogen bonds between the bases. The bases are joined together in a pair, single base chain from one. So nothing thus far is mentioning like how they're actually paired together, right? I know what purines are, I know pyrimidines are, but I don't actually know how they're paired together. One member of a chain must be a purine and the other must be a pyrimidine. Yes, this I do know, right? In order to bridge them between. So this might be the evidence that I need, right? Using what I've done before as my answer choice. I'm gonna keep reading though, just to understand a little bit better. It says, we believe the bases will present almost entirely in their own probable forms. If this is true, the conditions of forming hydrogen bonds are more restrictive. The only pair of bases possible are this. Okay, so this is what I need. So I know that there's a condition up here, how they bond, and then now here's where they tell me. Adenine binds with thymine and guanine binds with cytosine. So this is technically Chargaff's principles. So the numbers here, and for those of you in chemistry or biology, the numbers here refer to the numbers of hydrogen bonds. So notice what I'm doing. I'm taking outside knowledge, which actually can make this a little bit harder, right? But I know that adenine bonds with thymine. I know guanine is bonded with cytosine. Let's pretend you didn't know that outside knowledge, because you may not be as nerdy as I am. That's okay, right? They tell you right here. That's what you need to pay attention to. So the evidence is there. You just have to essentially find it and know that that's what you're looking for with respect to it being randomized. So adenine bonds with thymine, guanine bonds with cytosine. These are one purine with one pyrimidine, so that works as well, right? So all of this matches. So now I need to go and I need to figure out if this works inside of my table, right? So I know my adenine, oh, sorry about that. I know my adenine here and my thymine on the side over here, they should essentially be like, I guess, proportional, right? Because if they're being bound together. And I know my guanine is being bound to my cytosine, so these also should be proportional. So these guys and these guys should go together. Now, they are not going to make the numbers exact, but they're going to make them like relatively similar. That's what we need to basically go off of. So this is 26.8, this is 27, this is 22, this is 23, or 22.8, 23. Yeah, I would say there's relative. These are even equal here, right? 17.6, 17.6, 33, 31. This is 28, this is 28. This is 28.6, this is 28.4. Yeah, I would say they're relatively similar. 20, 20, 20.5, 20.7, 29. Yeah, these are even equal. Yeah. Okay, so there's in more than one place the numbers are matching up, and for multiple species. So I can essentially sort of conclude that it does work, right? And of how I'm breaking down this passage. And now, why did I do that, right? What was the $1 million reason of why I broke that down first, for those of you that are sort of like still paying attention, staying focused? Well, because notice what happens is you see this, yes, yes, no, no, right? If I can immediately figure out that they do work, right? That the table, what's inside of it, matches what's inside of the passage, then immediately I'm a yes guy. And if I'm a yes, then I'm getting rid of C and D. I'm not even reading these, right? Maybe I come back to it if the explanation doesn't make any sense. But I'm not spending time reading and sort of dissecting this. Instead, I'm just focusing on kind of the core context. This says yes because each given organism, the percentage of adenine is close to the percentage of thymine. So this works because remember, we said A goes with T, right? And guanine goes with cytosine. So this works, A works. However, we're still gonna read B. And we're gonna read B to make sure that we didn't miss or sort of overlook anything. Yes, because each organism, the percentage of adenine is close to the percentage of, okay, I see what they did here. So they just flipped it, right? This is not correct, right? So here for 29, A is gonna be my answer because of the fact that this is the condition, right, that works. And what does the data in the table support the author? Yeah, and it does. So the data in the table supports the author's claim that adenine is bonded to thymine and that guanine is bonded to cytosine. So once I figure that out, once I figure out what the condition is, then I just basically match it up to what is presented to me inside of the table, okay? Let's see, another question. For number 29, do you recommend us to find out the validity of the statement or first check, then check each of the answer choices? Ooh, that's a good question. It really depends on the statement and how quickly it is to find. I probably would say in this case, because it's so vague, you have to find the statement first. Because it says, do the data in the table support the author's claim? So if you're, basically, here's what I'm suggesting to you. If I'm looking at this table, and if I have no idea what to look for, I'm gonna be there for a while, right? If I'm looking at this table, and if I'm thinking to myself, what am I supposed to find? This is a very, like, that's a tough, I'm not gonna like that, like 2 minutes of trying to find whatever it is they want me to like take out of this. Here's one thing I can tell you. The values are different based off of the organisms. That's what I can like quickly tell you. But if I really want to figure out, without using outside knowledge, excuse me, if I really want to figure out that these are essentially equivalent, then I'm going to have to comb through a lot of these, and that's going to make it hard. So what I would say is it depends on the question of should you find the statement first or use the table. Sometimes in other tables, it might be easier to figure out whether it's like increasing or decreasing, right, in that aspect. In this instance, you probably need to find the statement first. And the reason is because there's just so much information. All these numbers here, you're not trying to really get into, and you don't do math. That's the other thing. For the SAT reading, you're not doing any math at all. You might be understanding like relationships and proportions and such, but you're not doing any math. So you should never be like calculating anything. There should never be any slopes or intercepts or none of that jazz, right? Instead, you just basically need to find the statement here and the statement below. That way you can match it up and make it correspond. So in this instance, find the statement first and then go to the table. If the table might be less, then use the table. So that way maybe you can better find the whatever it is that they're trying to tell you. All right. Now let's go to 31 quickly, and then I'll show you how to do one last question that isn't in this type of passage, but it's in another type of passage that I know many of you will utilize. 31, based on the table, blank is the percentage of adenine in each organism's DNA, the same, or does it vary? And well, this is what we already discussed. So it says, notice the questions get easier as well as you move on because you have more information. That's also something to kind of pay attention to. It says, is the percentage of adenine in each organism's DNA the same, or does it vary? In which statement made by the author is the most consistent? So in this instance, I want to go to the table first, right? That's going to be easier to decipher. So here it says, hey, is adenine the same? Well, let's take a quick peek. No, it's not. So for every single organism, it's almost different. 26.8, 33.2, 28, 28.6, 29, 29. There's only 2 organisms that have like relatively same percentage of adenine like throughout. Everything else is basically different. So don't get sucked into the 29.3, right? All of these are different overall. So because majority of them are different, I'm gonna say, yeah, they're gonna be different. Now, so now I wanna go to my statement, and for A, B, C, and D, and my statement says this, the same, it varies, it varies. Well, just like before, we're sort of consolidating. So I'm probably not going to read A or B unless I honestly feel like C and D are way wrong and don't make any sense at all. I'm probably only going to stick to C and D because I know that they're different. right? I know adenine is not the same, and I know that it does vary. Now, here's what I need to do. I need to think of words that are not the same. I need to think of words that mean like variations in some aspects, right? That's what I have to figure out. Differences, various types, right? Variations, right? I need to figure out other possible combinations, right? That's what I need to think about, which actually I think is the answer to this question. So if I go up, it's been a while since I've done this passage now. Then I go up, and then it says, thus one chain, or no, it's long molecule may have many different permutations, right? That's where my answer is going to be. And if I actually went back down, I would see here, it varies adenine, thymine, lines 36 to 38. And then it says it follows lines 41 through 45. I probably want to bump that out a little bit. I probably want to do 40 to 46, right? Read to the end of the sentence, as I mentioned before. And I'm going to go back to 40 to 46. And in terms of time, we're like sort of moving this a little bit more. So 40 is the phosphate sugar backbone of our model is completely regular, but any sequence of pairs based on convenient structure, it follows that in a long molecule, many different permutations or possible combinations, different variations are possible, and therefore it seems likely a precise sequence of bases of the code which carries. Yes, there you go. So the word different permutations is what my answer essentially is going to be. And that makes my overall answer choice D, right, as I work through, right? So this one, it varies. So whenever you're given a statement, you will either use the table or you will use the statement. It depends on what information is provided to you. I will say do the graphing questions last though, because more often than not, you will need information from the passage. Also notice we skipped a few of the questions. We skipped like 2 or 3 questions in the beginning, and that was just simply make time for the graphing questions towards the end. But you'll gather more information from these questions as you're actually doing it. As you answer every question, you'll be gathering more and more information. So that way, future questions, you have a much better idea of kind of what to do, all right? Now, I'm gonna do one last question one last major type of question, and also probably the most popular question that you'll face. So here's what I'm gonna do. I'm gonna go to an example I'm gonna do 9 and 10 from practice test 1, okay? So I'm just gonna quickly kind of show you guys sort of how to do what are called connection questions. So I'm gonna label it here. So 9 and 10 practice test 1, and then we'll be done for today. I'll miss you. Right. Okay, so why does Akira say his meeting with Chi is a matter of urgency? So I'm gonna circle this because these are 2 characters in the story, and I'm gonna circle matter of urgency, which is line 32. And then this is really lines 30, 31, 32, maybe 33, okay? And what I wanna do is also notice the word why. It's saying like, why does this matter? Now, whenever I'm doing questions, and I should have prefaced with this a little while ago, is I always want to sort of glance ahead, and because sometimes I will get these style of questions, which is called an evidence-based question, okay? And evidence-based questions are a little tricky because what most students will do, and for those of you like still hanging on, don't go anywhere because this is like super important, right? What evidence-based questions will do is they will assess if, like in this instance here, you do the first question first and then you go to the second question, which is a common mistake. Instead, what you want to do is you want to use these answer choices here, where line 39, line 39, 42, line 58 and 59, 72 through 73. So I want to use these knowing where to look, right? These help so you know where to look. So instead, you don't want to do 9 first and then skip to 10, right? Or just any sort of connection question. What you want to do instead, and this is a huge help for those of you that are still with us, is that when I read the question, I paraphrase the question of what I need, right? And I know I have to, and I do glance ahead, and I know that I'm going to need A, B, C, and D, right, from question 10. What you then do is you use these to first answer that question. Right? So don't even look at these yet, okay? Don't even look at A, B, C, and D and 9. Instead, what you do You try your best to read these through for number 10, then you answer the previous question. It's almost like they're giving you evidence, right? That's what you want to do first. Then you match it up, right? Then you'll go back after you develop your possible answer choice. Then you'll try to answer question number 9. So here's what I mean by this, like relatively quickly. This, normally, I don't want to trouble you, I think is the actual answer. So I'm going to go right there. So I'm going to go to 39. So 39, he says this. Says, in the dim light, his eyes shone with sincerity. She felt herself starting to like him. Calm on inside, get out of this nasty, surely your business. I don't want to trouble you. Normally, I would approach you more properly, but I've received word of a position. I have an opportunity to go to America, right, as a dentist for Seattle's Japanese community. If you haven't read this passage yet, I suggest you do so, right? Maybe try some of the strategies on this particular passage. But here's what I'll tell you, is that that's your answer, right, when you break down and you go through the passage. And my answer then will correspond, right? B will be my answer, which means that he has received a job offer, right? So I'm using my evidence first here for 10, and then I'm correlating it back to what the answers are, right? So that's how you approach connector questions. I use the evidence from the second part of the question or the second question to then address, right? Use that evidence first, answer that question, then go back and then correlate it back to A, B, C, and D of the previous question, right? So that's probably a huge piece of advice that I would give you. All right, so that's kind of everything for today. So before you guys go, I'm gonna quickly kind of repost the ACT. You guys need it for whatever particular reason. I do hope you're getting a lot of value out of the seminars. Once again, you are more than welcome to suggest which questions that you potentially would like covered. And if you have recommendations of, yeah, I'd like to do more equations of a circle or other particular reading passages or perhaps even certain things foundational within the English section, just let us know. We have our ACT seminar tomorrow, and then we will have the English seminar following, and then we'll kind of move on. We'll come back to some of the math, but I sincerely hope you guys are kind of staying safe, right, staying healthy, and you're doing your best to kind of take your time out, take time out for your friends, your family, and still staying on top of your studies, of course, because everything right is still happening. But if you need anything from us, sincerely, just feel free to drop us a message. I'll also leave the website here so that you have it. And at the same time, if you really enjoyed the seminars thus far, we'd love to hear your feedback. Feel free to kind of leave us like a review, Google review, Yelp, whatever it might be, whatever's the best method. So we're here for you. Just let us know what is going to be best for you guys, and we'll simply move forward. I will make sure to send a follow-up email to everyone that was here and participated today, so that we guys have the upcoming webinar and upcoming seminars, but also at the same time, any kind of additional videos that you guys might find helpful. So thank you again for everything. Thank you again for tuning in. I will see you guys on Tuesday night, but remember to tune in for the ACT Science if that is indeed something you're thinking about exploring. You're going to find it incredibly valuable. So best of luck with everything. Best of luck with your studies. Take care and enjoy the rest of your day. All right? All right. Take care, guys. Bye.